Right. I'm doing this video to show you how to do this using the complete calculator cheat method way. The average student loan debt is reported to be $25,235. A student believes that the loan debt is higher in her area. She takes a random sample of 100 students, and the mean happens to be 27,524, and a standard deviation 6,000. Is there sufficient evidence to support the student's claim at the 5% level of significance? So the first thing is you need to determine your null and alternative hypotheses. Well, the null and alternative hypotheses are never found in your sample data. The sample data is there to either provide evidence to support, the claim. That literally is why that sample evidence is there. So that's not something that is going to be part of the claim. Or the assumed to be true in information. So all of these numbers, it says a simple random sample of 100, the mean was this, those numbers are not going to be in your null or alternative hypotheses. But then now where you're going to find it is either in the claim itself. You're going to find what the number that you needs to be in the null hypothesis, or you're going to find it stated kind of as a fact in the beginning. So here they say the average loan debt is reported to be this. So they're stating it kind of as a fact. So that first answer there is 25,235. Then, because the claim says a student believes or is claiming, that the student loan is higher, right? So that means that when we set up this alternative hypothesis, the same number that was in the null hypothesis is also found in the alternative hypothesis. And because they're saying that they think the mean value of the student loan is higher, that's why we face the alligator's mouth toward the value, the variable that represents the mean here. So it says the mean student loan debt is higher, is bigger, right? Because the alligator's mouth is pointing toward that mean than 25,000. So that's what we want there. Then I know I already showed these answers, but then we're going to go to our calculator and now we're going to use our sample information to calculate and we're going to use our sample, but also the null alternative and to find our p-value. So the way we do that is we go to stats, and then we go over to tests, and then we go to t-test. I press enter. The mu naught here, that is the one that is in the null hypothesis, the one that we believe to be true. If you are given the raw data, then you want to click on data, and then you would, if they gave you if they gave you the 100 college student debts from each of the college students, then you would have entered all 100 numbers in your L1. They did not do that for us. They just gave us the mean and standard deviation. So then we picked on stats, and then we put in this mu sub 0 is what's coming from the null hypothesis. So that's the 25,230. Okay, then X bar is the mean of the sample. So it is 27,000. Okay, I erased it. I changed it. Let me erase it. Now our evidence, now we can pay attention to the sample data. So the sample data is 27,524. Then samples, this SX is sample standard deviation, so it's the 6,000. The N is the number in your sample, so that's 100, and then this has to match Oh, this is a little bit, I don't like this notation. They should have put this mu, just mu period. Mu is equal to, and the only ones that should have a mu not are the ones on the other side of the equal sign. So I don't really like this notation here, but it's just going to match what we have here. So it looks like an arrow pointing to the right. So just make sure it's an arrow pointing to the right. If you have your mu on the left and your number on the right of your real term hypothesis, then you can just make sure that your arrow is pointing the same way in your calculator. So there we go. Then I go down and I press, you can click on draw, or you can also click on just calculate. So I'm just gonna press calculate and then enter. This tells me, oh man. Oh, I didn't do this right because like it thinks I'm doing a two-tailed test of the not equal. So let me go back really quickly. Enter, usually it keeps all the data. So, I need to actually choose. Okay, I have to like scroll over, I think, to choose. Oh, I'm on the wrong. That's why. And I'm not sure why it's not wanting to let me do that. Okay, maybe I have to press enter. Yeah, okay, I had to press enter on, okay. Now enter, and now, okay, so this is for if we're trying to test the claim that the mean loan value is bigger than 25,000, then the test statistic is 3.815 and a p-value is 0.0001. And so we can plug in those values here. And those are the answers here. Next, we're going to be comparing this p-value to to the alpha, to the level of significance, which is the 5% right here. So we're written as a decimal, so 0.05. I always have to write it out 5% and then move it twice to the left. So it's 0.05. Okay, so you have to ask, is the p-value lower than alpha? And the answer is yes. So then we do reject the null hypothesis. So because 0.0001 is less than 0.05, because the p-value is less than alpha, then we reject the null hypothesis. So that's why the answer here is reject the null hypothesis. And then when we write our final conclusion, whenever we reject the null hypothesis, that means there is sufficient evidence to support the alternative hypothesis. And we can go back and read what the alternative hypothesis was. It was the mean loan debt being greater than 25,235. That means we do believe that is true. So we're going to say there is sufficient evidence to support the claim that student loan debt is higher than the 25,235. There we go. All right, hopefully it's helpful.